All right, 5.467. So this is the identity that we're supposed to prove, I'm guessing. Yeah, verify that each equation is an identity. Okay, so we have to verify that this thing is an identity. In 5.4, we talked about, what was the topic? Sum and difference identities for sine and tangent. Okay, so, well, here I've got some sums and differences of tangent. That could come in handy, like if I were using one of those identities kind of in reverse. But I'm more inclined to start with this side. Now, another thing I could try, well, so I'm inclined to start with this side and apply a difference identity and a sum identity, okay, to this. But another thing that we could try is, if we needed to, we could try the old trick of multiplying by the conjugate of the denominator here, to try to get this to be a single term if possible. And then we could split these. I don't know if that's going to really come in handy, but it's just something that kind of occurs to me that we could try. Another thing, of course, we could try is rewrite all these things in terms of sine and cosine and see what we get. We definitely get the same denominator, I think. And so then again, you could, potentially like cancel some stuff out. Anyway, so that might come in handy for manipulating the right-hand side. But my inclination is to start here on the left, rewrite these using a difference formula and a sum formula. Okay, so for sine x minus y over sine x plus y, I'm thinking we'll do sine x, sine y. Oh, no. For sine, it switches, doesn't it? This is sine x cosine y minus cosine x sine y. I better check to make sure that I did that right. But I think that's right. And then here would be sine x cosine y plus cosine x sine y. Really tempting to try to cancel those. Doesn't work that way though. Let me make sure I use the right difference formulas. Sine x cosine y plus cosine x. Yeah. Okay. Okay. Oh man, that's kind of nasty, isn't it? I don't know if that's really all that useful. Now that I'm looking at it, somehow we've got to get this to be tangent x minus tangent y over tangent x plus tangent y. Well, we could force it, we could force it. It's like, that you're trying to get to here. In order to force this first term to be tangent x, I really need to have a cosine. I need to divide by a cosine x, right? If I divide this top term by cosine x, then that'll get rid of that cosine x right there, which might actually be a good thing. And by the same token, if I'm trying to get tangent y over here, I need to have a cosine y on the denominator. So here's what I think I'm going to do. I think I'm going to multiply by 1 over cosine x cosine y because I think that's going to get me what I want, right? Like when I distribute here, the cosine y's will cancel. I'll be left with sine x over cosine x. When I distribute here, the cosine x's will cancel. I'll be left with sine y over cosine y. Right? And then a very similar thing happens in the denominator, right? When I distribute here, the cosine y's cancel. I'm left with sine x over cosine x. When I distribute here, the cosine x is canceled. I'm left with sine y over cosine y. And there it is. Okay. Right, this is tangent x, tangent y, tangent x, tangent y. That one was kind of fun, honestly. That one was, see, don't you love these trig identities? Like your opportunity to kind of be creative. Anyway, liked that one.